Next up, we have Joel from Jamf, who's going to be talking about some interesting topics that I don't know much about. So I'm actually really excited to hear about this. So let's give Joel a round of applause.
Thank you. Since I know everyone has lunch reservations for 12:45, I've doubled most of my slides in this so that we can have time. Plus, with a little bit of luck, I've got some live cooking in here, but I seem to be shorter than most. We have assistants. Thank you. Get rid of this. All right. Fantastic. Uh-oh, you can see me looking for last-minute additions. All right. Hello.
Hi.
I'm the last thing between you and lunch. I'm the hype person for lunch. Is that what I got to do? All right, we're talking about FIDO, Fast Identity Online, something that I've been having a lot of fun with the last maybe year or so, especially as it's gotten a little more mature and has kind of come into wider usage. A lot more identity providers are supporting it by default, and you're seeing a lot of people, including Apple, working it into the system a lot more than it ever was before. So that's a fantastic time to learn more about it and also see what you can do about maybe trying to subvert it or bend it to your will. So I'm Joel. I do identity things, as Patrick mentioned, at Jamf. And then for the most part, you can find me places under the name MacTroll. There's a long story there, but that's for later. So there we go. All right. This is the non-clickbait headline that I'm going to put in here. No matter what I talk about over the next 30, 45 minutes, FIDO is pretty much in every way more secure and more usable than using a password, all right? So there's no intent to scare. I'm not trying to fear-monger here. I want very much to have more FIDO, have public-private key being used for authentication. That's fantastic, right? But as with all things, it's something that we should understand and be aware of before we dive into it. The focus here is going to be on macOS. That's because it's just a little bit easier to demo, a little bit easier to debug. The good thing about what Apple has done, and since this is very heavily browser-focused and things like that, almost everything that I show here is completely replicable to iOS, all right? With the exception of maybe it's a little harder to fit a USB security key into your phone, but you can do that over NFC and some other things. Other really nice thing is with iOS 15 being out, you can have extensions in Safari that are pretty much identical to extensions that you would have in Chrome or on Safari on the Mac. And so some of the things that we're going to do a little bit later will be, again, very replicable on iOS as well as you go through that. So just keep that in mind as we go. All right, FIDO in 30 seconds before we get into doing the fun things. Probably the biggest place where FIDO came out, although you wouldn't know it because they don't really reference FIDO, but Windows Hello. When you're using a security key or something like that, Windows Hello for Business, I think specifically, you can use YubiKey, Thetis, Phaeton, a couple of them that are out there, to sign into your Windows PC, and it works really well. Tied into your Azure account, it's a really smooth flow. It'd be really great to have more of that on the Mac side, actually, as you go there. Over the last couple of years, you've seen, again, pretty much any and every IDP has now supported FIDO authentication, including as far as Facebook. You can sign into your personal Facebook with a FIDO key. GitHub supports it now, and then pretty much all of the major identity providers. Apologies to anyone in this room who supports it, but I didn't put your logo on the slide because I know it's a lot more than just this. So as we go and talk about FIDO, let's kind of break it down to a couple of component parts. There's primarily three kind of buckets of things that we're talking about when we talk FIDO. You have the relying party, which is the web page, the service, the identity provider, whatever that you may be using, that's going to be authenticating you. You have your Mac, which is your platform. Your iPhone would be your platform. Sometimes, because we've got to be very confusing in this industry, it's sometimes called the user agent, even though it has nothing to do with your user agent string. All right, so you sometimes hear it referred to that. So that's the platform. That's typically seen as the browser. So if you're going to be doing FIDO within Chrome or Safari or Opera or Firefox or whatever your preferred browser is, that's going to be what's mostly managing the interaction between that relying party. And then the third piece here, which is your FIDO key or your authenticator. Authenticator can be primarily two different kinds. You can have external authenticators, sometimes known as roaming authenticators, sometimes known as cross-platform authenticators, and those are going to be your YubiKeys, your Thetis, your Feiqians, and the other ones like that. And then you can have platform authenticators, and Apple's done a lot of good work here, allowing you to use Face ID, Touch ID on your devices, so they've implemented actually a layer of biometrics into this, right? Between the relying party and the platform, it's primarily WebAuthn. And sometimes you'll actually hear this not referred to as any sort of FIDO authentication, but you'll have it fall under the WebAuthn bucket. In particular, if your backend key is not FIDO compliant, you will refer to this as a WebAuthn transaction instead of anything to do with FIDO. I'll direct you to Apple's new syncing cloud keys that do not mention FIDO anywhere in there, but they heavily make use of the WebAuthn name, all right? So WebAuthn is the part between the relying party and the browser, and then between your browser and your FIDO key, it's typically CTAP, client to authenticator protocol. That's the actual protocol that's going in between there. And it's typically done over CBOR, concise binary ordering representation, right? Similar to ASN1, but not quite the same as you have that. So these are kind of the major components that we've got there. Here's the travel set of keys that I have that I take with me. Sam, I believe, has a few more. We've been comparing, oh, do you have the K33? Oh no, I've only got the K35 in Google packaging. So you can see there's a variety of names and identities and other things. Most of them are going to be USB based in some form. That's typically the most common. They'll also show up in NFC if you're using that with your phone or mobile device. Also can show up over Bluetooth. Although Bluetooth kind of became a bag of screaming cats, and support for that is kind of iffy as you go through. There's also some fun things where people have tried to combine FIDO with a lot of other form factors. So there's a smart card there with a very small battery in it that can actually do Bluetooth and FIDO in addition to actually operating as a smart card as well. Right? So a lot of different form factors that are in there. You can have some that keep your Bitcoin, right? This is Trezor, I don't know the exact pronunciation. But a lot of folks will mingle the FIDO piece with some sort of Bitcoin wallet. Under the covers, it's P256 keys primarily. All right, so there is a good crossover between what you're doing that. This one's got a nice LED display on it that you can do some work with. Here's one that I don't think is sold. This is Motive, but it was a FIDO key that you could wear as a ring. And to prove it was still you, it had some patented method of determining your gait and how you held your hands. And so as long as you were still gesticulating the way you normally gesticulated, it would allow you to do this kind of magic hand wave and do a FIDO operation. It was kind of cool. I don't know how well it did. They got bought by one of the other wearable companies. So probably fantastic for the people that owned and had started that. Here's another one. I find this kind of fascinating. It's got a nice LED display. It's a couple inches long. And its method of proving you were using it was you would write out your PIN code. And had the ability to do handwriting recognition as you would write your PIN code on the table. So some folks have come up with some really interesting ways on these hardware pieces. However, I do believe that the vast majority of users are going to use what they already have in front of them. And that primarily is then going to be Face ID or Touch ID if you're on an Apple device. It's certainly the path of least resistance as we go forward, right? So the hardware ones are cool. I'm not a hardware hacker, so we're going to focus from here on out mostly on things you can do with the platform authenticators and without having an authenticator attached at all right? I'm sure there's probably vulnerabilities in some of these hardware, but I'm not the one that's going to find those, so I've focused just on the platforms and other places that you can get to. All right. With that as kind of a couple of ground concepts of what FIDO is, let's get into kind of some of the fun things that you can play around with as a security researcher or someone who's just curious about this situation. One of the basic precepts about FIDO, and this is really great specifically in the consumer space, it gets a little bit more annoying in the enterprise space, is that FIDO has a very strong focus on anonymity. Whenever you sign up for a new service, whenever you use your FIDO key to create a new credential, there's nothing that should relate that credential to any other credential that may be on your FIDO key, all right? They're both just random P256 key pairs, and there shouldn't be anything that can connect those two together. Of course, maybe that's not always the case. as we'll see in a little bit. So vendors do unique things. Sometimes vendors follow the protocols very well, sometimes they don't follow the protocols very well. And then when some vendors don't follow the protocols very well, other vendors have to then relax their adherence to the protocol to be able to allow users to use the things they think should work so that they're calling the right vendor when it doesn't work instead of the one vendor that was actually following the protocol but seems like they're the one that broke it. Whew. I'll show you this. So there's a couple of pieces when you go through a FIDO authentication. One is there's a key ID length. When you send your public key off to the relying party, you've got to give it some sort of name or some sort of identifier. And that's the key ID, right? Usually a bunch of base 64 can be of any length up to, I think the protocol is an unsigned 32-bit integer, which is 64,000 bits or something like that. Anyway, a lot. Fun fact, you can actually go over that and great things happen. All right, there's also a sign count. In the attempt to prevent an authenticator from maybe getting cloned and used somewhere else, every time the authenticator makes a signature, so every time it proves who it is, it should keep an internal count of how many signing events that have happened. If you're the relying party, you're supposed to keep track of this so that if I sign in from one place and the sign count is 15, but then I sign in from another place and the sign count is 10, that's a bad thing, right? That means that somebody might have compromised my key, it might have cloned my credential, and now they're using it in a different place, right? So there's a sign count that's built into this. All right, let's do a demo. We got some live cooking of some things here that should be fun. And if not, you can go to lunch. All right, this is one of my favorite sites when you're playing around with WebAuthn. It's called WebAuthn.me, and it's got a whole debugging page. There's another one from Singular Key that's really nice. Singular Key, I think, got purchased today. Congratulations to anybody from Singular Key. Got picked up by Ping. I noticed that when I logged into their site today. So this is WebAuthn.me, and if you scroll down, you're able to go through and kind of pick all of the settings. You can kind of look at what the protocol allows for and go in and just kind of edit these. It's really cool. And if I hit register, this is what a typical user sees in Chrome. So I'm getting the option of either using an external key. I could plug in one of these devices and then use that USB setting at the top, or I can actually use this device, all right? And I'm gonna go down to this device. Whoop, I timed out, too slow. Go to this device, and now I'm gonna get prompted to take my finger and put it on the Touch ID. And when I've done that, I've now generated a brand new P256 key. Pretty cool. Back to the number one idea from this session, FIDO keys are always better than passwords. Having a P256 key is amazing, right? I can now do PKI, I'm doing a signature to prove who I am, and I haven't looked at the Chromium code, but I'm gonna trust them a little bit. It's most likely actually secured within the secure enclave. Since P256 keys can be generated from the secure enclave, Google should be doing that, and now I have an incredibly strong authentication process built into my device without having to buy anything external, plug it in, or anything else like that. Pretty cool, right? Well, some fun things that they do. First of all, we'll note this for later, the credential ID is always 80 bytes, all right? It's one of the ways that even though the keys should be completely anonymous, each key, and I'll give you a chart from what I've kind of found, has a particular fingerprint. That's probably too strong of a word, a particular type. So the Chrome browser will always do 80-byte keys. If you're seeing a FIDO transaction and you see 80-byte keys, you're most likely, that's Chrome, all right? So it's a good way of doing that. The other thing here, if we look up and there's a sign count that gets issued, like I said, every time you have this, you get a sign count for what this is. So I'm gonna, and this sign count here is 1633124315. Who can tell me what that is? It's a timestamp. It's a timestamp from like 5 seconds ago. Do you think you can predict the signature count that's gonna come with every key operation that's performed by Chrome? Yes. Every time it performs a signature operation, it just uses the current timestamp and it iterates forward. On the one hand, this is maybe clever. It's always advancing. No matter where that key is being used anywhere else, it's gonna be that. It is predictable, but then the signature count is always supposed to go up. So if you were an attacker, you could probably just guess at a really large 32-bit integer and use that as your signature account. So I'm not certain that this is a real flaw in any way, but it does do a couple of things. One, it's made most of the vendors ignore the sign count, all right? And we'll show you the even worse reason why most vendors ignore the sign count shortly. It also means that this is another identifying factor. If you are looking at a FIDO transaction and you do see a signature count that amazingly matches a timestamp from maybe seconds ago, you also have a really good indication that you're looking at somebody that's using Chrome, all right? So some cool things there. The other thing that they're doing, we didn't ask for an attestation statement. We're going to talk about that later. But Chrome always supplies an AA GUID, an authenticator generic or universal ID. Right? These are supposed to be unique for each authenticator, and this one is. However, they always send it whether you ask for attestation or not. When we flip over to Safari here, you're going to see that Safari and every other key that I've tested will send all zeros unless you're asking for an attestation to actually be given. All right? So it's another indicator that this is coming from Chrome as a browser. So now, if we go over to Safari and we go to this same page, and we kind of go through the same operation here. So hit debugger, scroll down, and we're just going to hit register, and we're going to hit continue, and I'm going to tap my finger, and now I'm going to have the same process done by Safari. And you're going to notice a couple of different things. First of all, the AA GUID is 0, all right? That's what it's supposed to be. It should be zeroed out, so we're not leaking any sort of identifying information about what piece of hardware that we have here. The key size is 20, so the credential ID length is 20 bytes. And I shouldn't say the key size isn't 20, the key size is a P256. The credential ID, which is the handle for the key, is 20 bytes in length. It's very short. Most of the hardware devices, because unless you're using a resident key, the key is encrypted into the key handle. It's kind of a clever way of doing these things, right? In this case, it's 20 bytes, kind of a big tip-off is coming from Safari, right? Other thing here, they have a sign count of 0, which is appropriate for this time, because we've just created this key, right? But now I'm going to go over and I'm actually going to use this key. So WebAuthn.me has the ability to just hit authenticate. I'm going to hit authenticate. Safari pops this up, says account from security keys. Great. It's a nice little UI, and I wasn't fast enough. So Safari pops this up. Going to hit continue, hit Touch ID again, and I will have just generated a signature. All right. The signature is there's some client data, there's an origin, there's a couple of things that are done. It's hashed, and then there's a signature performed over that hash. And then that proves that you have access to that private key. It's a nice, fairly smooth way of doing this, and I think it's a really good protocol for that aspect. Safari, however, comes down here, and the sign count is still 0. If I go back to Chrome, and I use this same key that I just authenticated with, you will see the sign count is incremented up. Of course, it also happens to be the current timestamp. So because of this, you have this interesting behavior between these two. With the Safari platform authenticator always returning 0, a lot of the relying parties have had to ignore the signature count, all right? Because if they want to be compatible, if they want grandma, if they want other folks to be able to use this and to be able to use the hardware that's in front of them, you have to start ignoring that signature count or expecting it to be 0 across the way. So again, not bad. I don't know that that's an attack by any means, but just an interesting little learning as we've gone through this. All right, back to the slides. There's Keynote. So here's a quick little chart, non-authoritative, non-guaranteed, not for use in nuclear reactors or in medical devices, of going through a lot of the keys that I had on hand. You can kind of see that there is some differences. Ubico, for example, is a 64-byte ID length, and that distinguishes it a little bit from Thetis and Phaeton and some of the others. Some have signature counts that are based on the device, so they just have a common signature count for every key on that device. Some have a signature count that's based on the key. Some have one that have a little bit of a random jitter in it. Pretty much all of them return all zeros if you're not asking for attestation. However, the Apple platform, it's 20 bytes. The signature count is always zeros. They do a good job of the AA GUIDs. On the attestation, it gets a little bit complicated. We'll talk about that shortly as we get into that. And then with Chrome, they do attestation where they self-attest. With an attestation in FIDO, the requirement is that you don't have an attestation that encompasses less than 100,000 devices, right? So you're signing it with a private key that was burned in at the factory, and that private key is the same private key on up to, or hopefully more than, 100,000 other devices. And that way, even though you get this attestation that proves this came from this particular piece of hardware, this brand, all right, you're going to get a similar attestation statement from other devices in there. That would require Apple or anybody doing a platform to ship an actual private key on your platform that is shared with a number of other ones. And that's kind of a complicated problem. And so Apple does not really do attestation. I think there's good reasons for that until we get to the syncing platform authenticators, which we'll talk about shortly. And then on the Chrome platform, they do a self-attestation. The private key that's generated when you generate a new FIDO key is then used to perform an attestation statement. So it's effectively signing its own key and saying, this is my key, I'm proving that I have it, which is a valid way of doing it. A lot of relying parties have just decided to ignore the attestation, is unfortunately what has come out of this. We'll cover that shortly. All right, recently Apple came out with the syncing platform authenticator. Apple thought this was really cool. I agree, it is cool, right? Because one of the issues with FIDO, if you're going to use the platform authenticator, the one that's built into your laptop, the key is ensconced within the secure enclave, you don't have that same key on your phone. So if I sign into Facebook on my Mac, and then I go over to Facebook on my phone, I've got to have a different key, a different method of signing in. And there is a little bit of complexity, especially when you're talking about consumers, for having to enroll each of their devices as a hardware key, right? So starting with macOS Monterey or iOS 15, Apple now has the option of doing what they call a syncing platform authenticator. They don't reference this as FIDO because it's not technically FIDO compliant. FIDO requires that the key is locked into hardware, and here Apple is now putting your keys into your iCloud keychain. So if you create an account in GitHub using a FIDO key on your Mac and you have an iCloud account, that key will then be replicated through your iCloud keychain and will be available on other devices that you've enrolled into that iCloud account. Pretty simple, pretty easy. If you happen to crack somebody's iCloud account, of course, you now have these keys there, all right? Goods and bads to convenience here. It is a little weird. As I mentioned earlier, authenticators can fall under a platform bucket or a cross-platform bucket. This is technically a cross-platform authenticator because it crosses platforms. It's the same key showing up in multiple places. Apple is still reporting it as a platform authenticator. So you do have some confusion with services such as Azure and Windows Hello who are looking for a specific cross-platform authenticator. We'll show you how to correct that shortly. All right. So anytime you come into a new protocol, something that's interesting to you, what do? Well, you try to get involved and you try to get wedged into that process, right? If it's an internet protocol, you set up a reverse proxy, you start looking at what's going through, you can see what you can poke at. Well, how do you do this with FIDO? Well, you can interrupt the flow, all right? When a relying party is using a FIDO key for authentication, it's calling a couple of APIs in the browser. The first one is navigator credentials create. That will actually create the credential. So your web page, whatever language or whatever you're doing, you can call the navigator credentials create API. That API is provided by the browser itself. The browser then goes and does the things that it wants to do. All right? There is also a corresponding navigator credentials get. This is where you pass in the key handle, then allow the browser to try and find that key, get the user to touch it, fondle it, do whatever they can to prove their user presence, and then that completes that process as they go through, all right? So these are the two main APIs that a lot of relying parties are using. Beautiful thing, JavaScript, injection, cool stuff, you can override these, all right? So if you wanna have a little bit of entry point within this. Obviously, hacking hardware is typically fairly high, complexity. But getting into the browser, if you can find a way to do that, if you can get in with a content script and overwrite these functions, you'll effectively own this whole process. All right. Now, good thing is, and I'll tap the sign, FIDO is more secure than passwords in pretty much every way. So even if you are in the flow, there's still a lot of things you can't do. I mean, we're still talking about signatures, we're still talking about PKI. However, you have a much better chance of leveraging any purchase that you have in here as you go through. So it also gives you a way of providing FIDO services within a custom web view or other web window, one of the embedded ones that you have there, because otherwise FIDO really won't work out of the box with those. So once you have control, what can you do? You can change the attestation requirements. If the relying party is asking for a platform authenticator, you can flip that to cross-platform, and then you can pass it to the real navigator credentials create function, at which point you'll have bypassed whatever the relying party is trying to ask for. The response from the authenticator has no indication as to whether it's a platform or cross-platform authenticator. So once you flip this in the request, it's off to the races from there, right? So that's one thing you can do. You can change or add an attestation. When you create a key, an attestation statement can be added, proving that this key came from a certain piece of hardware. That attestation statement can be removed, swapped out for something else. All right, so you can actually provide an attestation within a web extension, which is kind of fun. We'll show you that in a little bit. Here's a little diagram from Mozilla, and shows you kind of how this works from more of a developer's perspective. And what we're going to do is we're putting our web extension right here. All right, so that's where we're going to fit. And again, just a web extension, Chrome, Safari, all I've tested this with that. Safari on iOS 15 with the new extensions, you can do this as well and put these places in. So the first thing that you need to do is you need to provide a public key credential. Is user verifying platform authenticator available? This is the function that tells the relying party that you are FIDO capable. So as long as you respond with a promise that results to yes, and this is my first JavaScript ever that you're going to see, so if I get any of the JavaScript things wrong, please correct me. So as long as you respond with a promise that says yes, the relying party believes you can do FIDO operations. So that's the first piece. Once you've done that, you can take over navigator credentials create. A dictionary of options is passed to this function, just some JSON with a challenge and a couple other pieces in it. That's where you can have your fun, pass that on to the real function if you want to, and then navigator credentials get. This is where the relying party says, okay, I know you have a key, you've already registered it with me, I want to now do an authentication operation, so I'm going to pass this down to you. All right, very similar. You get a bundle of options, play around with those, do whatever you need to. This is not as interesting. Well, it is very interesting, but it's not as interesting from a getting wedged into the process perspective. Because at this point in time, it's just asking for a signature from a private key that it already knows the public side. So I'm not really certain that there's a lot of nefarious things you can do at this stage, but certainly in the navigator credentials create is where if you were an attacker, you'd probably think about having a little bit more fun. All right, here's my really awful, this is like only the second or third time I've written JavaScript. It's mostly cut and paste from Stack Overflow, so forgive me. But here's what you can do. You add this into a content script, injecting this content script through a web extension or some other way, getting it into the web page. You can wrap the real create functionality. All right, so you'll package that up, you'll set it to the side, you'll provide your own function to do that. And in this particular case, all I'm doing is logging out what's going through. If you are troubleshooting any sort of FIDO authentication issues, it is a little bit complicated to get the browser to give up what's going on. That's not a bad thing. However, if you want to troubleshoot it, see what's being asked for, seeing what the response is coming back from, this is an easy way of doing that. All right, and that just shows you. So all we're doing here is we're creating our own navigator credentials create, and once we have just logged the options that are going through, we pass the options unmolested to the real navigator credentials create function. And that way the user doesn't even know anything's changed. This is a really great thing about this. They'll still get prompted for Touch ID, the origin, all that stuff will work as expected, and then the response will come in, we log the response, and then move from there. So it's a pretty slick way of doing this. So let's do a demo. All right, so I'm gonna go back into Chrome here, and I'm gonna go to the singular key page. Again, it's a really nice just a debugger for this. And I'm going to open up the JavaScript console. And I've got a web extension here already loaded, and it's going to provide then some logging. And if I hit register here, you can see I'm already starting to log out everything that's going through. So now I've got the ability to see what's going through this process. I'm going to use my Touch ID here, and then I can see the actual response. This debugging page actually gives it to you here as well, so you can actually compare and contrast. But if you're not on a page that happens to have a debug console built in, this is a nice way of seeing what's going in and out of the process, all right? And again, it just shows up here. You can kind of take a look. This is the, I think it's the CBOR as base64 encoding, so you could go into cbor.me or some other places, decode that, and you can actually see what's going on there. So once you get it into JavaScript and once you get that web extension in there, it's pretty easy to then log out what you need to or make changes as you'd like to going through there. All right, so that is there. All right, so again, FIDO is more secure than using a password in every way, all right? Good, we'll keep reiterating that. But it's a good way of entering in keys can lie. A basic precept of FIDO authentication, and this is why it's so good for protection against phishing, is that when you interact with a key, you have to have some degree of user presence, right? If you've got the YubiKeys, you've got this little disk, you've got to press the disk. If you've got the ones that are USB-C, you've got to make sure you find little contacts and don't accidentally hit them when you paste your one-time password into Slack or whatever else, right? So you've got to have some sort of interaction with the key to prove you're there. This is a really good thing, right? And it is anti-phishing protection. If you happen to run across a drive-by or something else that's trying to use your credentials, there's at least some physical interaction that's required before your credentials are going to be used in potentially a malicious way. So that's great. However, all of these are set by the key, all right? It's the key that determines whether user presence has actually happened or not. Let's show why this matters. All right, who's familiar with the Cloudflare challenge? All right, wow, okay. Cool, well this is good. Then it's a learning experience for everyone. All right, so this is the Cloudflare challenge. Who likes CAPTCHAs? Thank you, Sam. All right, if you're tired of picking out buses and bicycles and street signs or whatever else, Cloudflare presented this as a way of requiring an actual user, right? Because what is a CAPTCHA doing? It's presumably proving that you're a human, right? You're not some sort of artificial Turk or something else like that, mechanical Turk that's just running through this. You're in fact an actual human behind the screen that's being able to do that. Or you're training a machine learning algorithm, absolutely. But I don't think we're training it very well, because it keeps asking me the same questions. Just to be a pain, that's good. That's rebel. So here we are at the Cloudflare challenge. I'm gonna try verify with CAP, and I'm gonna do this through here, and I'm gonna fail. And I'm failing because there's no attestation format, all right? Because these platform authenticators in Chrome and Safari don't have a way of doing attestation, they'll put a big asterisk on that, but we'll leave that alone for now. They can't pass through this, even though I did do a user interaction. If I used one of my FIDO keys from, Yubico, whatever, Thetis, whatever, we'd be able to get through that. However, I look at this and I said, well, this could be fun to play around with. So what do you do when you want to play around with things? Well, you get a tool. And this tool, now that I've lost my cursor, come back here. There we go. Keynote was hogging it. So this is a software-based FIDO key. I've loaded in these Java or these APIs that I explained before, the Navigator credentials create, Navigator credentials get. And I've actually backed this entirely with my own code. So now I'm able to actually do attestation statements. So in this case, I'm at the same Cloudflare challenge. I'm gonna start out with this, and it's gonna fail, right? Because I'm not providing an attestation statement. You notice my hands didn't touch anything, all right? Since I own the key, I can lie about the user presence. All right. Now I'm going to select attestation here, and I'm going to retry this. And again, no touching keys, and I've successfully actually navigated through the Cloudflare challenge. All right. Because again, since I own the key, I can lie about whether user presence was there. I can say the user was fully verified. I can add my own attestation. I can generate a credential ID length of 50,000 bytes and see if I hit an overflow or some other way. So it's kind of a fun fuzzing tool that I've been playing around with and looking at how you can interact with some of these places. And lest you think I'm just making this up, Here's an Okta login, and I'm going to sign in with an account here. And first it's going to prompt me for my password, which hopefully I remember. All right. And now it says, hey, you've got a policy that says you need to enroll an authenticator. Well, sure, I've got an authenticator. So MFA enrollment required, great. Click on that. I want to do a security key, set up, and configure factor, enroll. And now I've just enrolled a key in Okta. Pretty cool, right? A stunned silence in the room, I guess that's good. And now, to pass the hoop over the floating assistant, what I'm going to go back into is I'm going to sign out, and I'm going to go back in and authenticate as this user. This is Okta factor sequencing, so I don't even need a password. I can just hit this, and I'll verify, and now I'm in my Okta dashboard. All right. Woo! I actually think this is pretty cool. I do a lot with mutual TLS, which is tried and true, very good way of doing authentication. The world does not seem to be excited about mutual TLS going forward. WebAuthn seems to be the new hotness. And I think this is an interesting way of possibly doing WebAuthn instead of mutual TLS by doing this kind of transaction under the covers. Right? Since my key is software-based, I could do things such as continuous conditional access. There's other options that I have in here to validate that you are who you say you are and you are on a trusted platform. All right, so some interesting things there. And just in case you think I'm picking on Okta, here I'm going to go log into one login. Oh, let me log out, and I'll show you that the same thing works there. And I don't necessarily see this as any kind of security issue. It says here's WebAuthn, and now I'm going to be authenticated, and I'm sitting at my dashboard by having gone through there. Pretty cool, passwordless, right? Exciting. This isn't a problem with relying parties. It's more, you've got to be trusting of the browser that you're using. If I own your platform, I can start doing things like this that maybe the user wasn't even expecting, right? And one of the potential attacks here would be if I can get wedged into your browser in this format, the user thinks they're using their Touch ID, all right? But I could have actually done the entire operation regardless of what the platform sends back to me. However, I could let the platform be triggered every time, so the user would still thinking they've got the security of Touch ID, Face ID, whatever being involved in this. But in the meantime, I've exfiltrated the key, all right? Because I'm not as nice as Google and Apple, and I don't keep credentials in the secure enclave, because that makes them harder, right? So this is one of the ways that these platform authenticators or FIDO keys in general can lie if you don't trust the key. A lot of this comes back to the attestation statement, right? So the attestation statement should prove that your key is a good key, all right? It should have a good connection between this is from a known batch from a vendor that I trust that does the right thing. However, with the platforms themselves, Safari and Google not providing attestation for very valid reasons, but it's caused most of the relying parties to just bail on either bothering to do the attestation checks. And that allows me to then use my own software-based key for these things. All right. So only trust keys with attestation? Maybe. I don't know, right? On the one hand, FIDO is much more secure than passwords. So I'd prefer that anybody use a FIDO key, use PKI to do this authentication as opposed to a password. On the other hand, you've got some rough edges, all right? Be aware of that. Speaking of attestation, all right, so this is when you issue a navigator credentials create command. This is the response that comes back from the authenticator key. So you get a couple of things. Here's the public side of a P256 key, pretty explanatory there. There's the key ID, so that's the key handle that references the key on that authenticator, so that when you get requested to log in again, you do a signing operation, that's the key handle that's going to be used, all right? The relying party stores the public key, and it makes it a very easy way of validating that you have the right private key when you've done that signature. Again, basic PKI. There's a set of flags in there, the user present, user reserved. None of this is really signed by the key that you've created, because the belief was if you just created the key, why do you need to sign it? Because it's all coming back in an atomic operation. However, if you are involved in the middle, you would be able to actually change these flags, all right? There's an attestation statement here up at the top, And this is a signature that's run over this chunk of auth data, all right? And again, if you're on a hardware key that has an attestation key, that's going to be a private key that was burned into the factory that's on up to hopefully more than 100,000 authenticators. So that way you can validate that it is coming from a particular piece of hardware. If you don't have that attestation because you're in a browser and you don't have that access to that burned-in key, then you can add in whatever attestation you want. And that would allow you to manipulate other pieces within this auth data, sign it with your own attestation statement, and then send it up, or just remove the attestation statement. Since most relying parties don't care whether attestation comes or not when you're creating this key, that does give you some opportunities here. All right, another demo we've got. If I go back into, I've got Safari Developer Preview. Where is that? Here it is. All right, Safari Technology Preview. And what I've got here, and I need to, this is Keynote hogging the cursor again. There we are. All right, let's make this bigger so y'all can see this. So I've got here just that same debug page in WebAuthn.me, and I'm going to ask for direct attestation. So I'm going to say, create me a key. I'm going to use the platform authenticator. I've got platform up here. I'm going to say, create me a key and do an attestation for it. And if I go down here and hit register, I'm going to hit continue. I'm going to touch ID, and I'm going to get the shake. All right? Because the Apple Platform Authenticator says I can't do direct attestation, so too bad, so sad. Right? However, if I go to my preferences, I have a Apple FIDO Key Manager. It's a web extension. I'm not sure where it came from. I must have installed something on my device. Now, granted, this is not an easy hurdle, right? Getting a web extension installed in Safari is not trivial, but it's certainly not impossible. Especially not when you call it something very intriguing and you put a logo on it that may match somebody else's. So I'm just going to hit this and I'm going to enable it. And now I'm going to go back into here. I'm going to open up the console. Actually, you don't need to see the console. We'll do this again. And then I just need to reload the page so it makes sure that I load that web extension. And I can go back here to attestation and I can say direct. And let's make it a cross-platform. I think I'm already covering that. And if I hit register, again, it says, do you want to save a passkey? So I can hit continue. I'm prompted to do my Touch ID, and now I actually have a key that was created. However, what I've done is I've added in an attestation object on the way back from the platform authenticator back into the web page. Another hushed silence. Wow, that's exciting. Woo! All right. So I think there's some fun things that can be done here. If you're following along at home, this signature is garbage. I don't know how to sign things in JSON, so I've just put in a bunch of random bits. But it does fit the actual formatting. But if the relying party, WebAuthn.me, it's a great site, but it doesn't actually validate the information that it's given, right? So if this was a real relying party, they'd find that this signature didn't match. However, there's no reason to believe that if I knew more about JavaScript, I'd be able to do that signature and finish that up, right? So that's a place to go into there. And if I download this key, I think I grabbed I think I just took an attestation statement from YubiKey and I threw it in here. So it would be a valid certificate, it just wouldn't be a valid signature. So all kinds of fun that you can have there. So that's some of the things that you can do with these web extensions as you go through there. So how do you protect yourself against this? Unfortunately, it's complicated, right? If you go to Okta and you enable FIDO, WebAuthn, you don't have an option of trusting just one set of attestation certificates or not. There's goods and bads to that. Good thing is it becomes much more usable for more people. And again, FIDO authentication is more secure than passwords in every way, all right? However, as a enterprise, as somebody who wants to be a little more controlling over what keys users may use, you don't have that option. Unless you think I'm picking on Okta, one login, same thing. This is the options that you have in one login for determining what FIDO keys can be used for your organization. You get to pick the icon and then call it something. You have that. If you go into Azure, Azure's got a little bit more here. And in fact, you can enforce attestation and you can actually enforce key restrictions. So you can go in there and actually set specific, I think when you enforce attestation, it goes back, FIDO Alliance keeps a metadata server of all the validated, authorized FIDO devices out there and attestation statements, and Azure will go back to that metadata server and require that your key actually have one of those validated statements or validated certificate chains in there. And so that's what happens when you turn on enforce attestation. Of course, at that point, nobody can use Safari or Google or Chrome, excuse me, for the built-in platform authenticators. So there is a trade-off as you go into that. Azure also allows you to enforce key restrictions. And when you enforce those key restrictions, you can actually limit it to an AA GUID, so actually a little more specific to a device type. All right. And so there's some cool things to do, but there's some pretty big trade-offs. And I'm not familiar with that many places that have actually enabled a lot of these. Although I think the attestation is on by default. But if you turn that off, then you've got some more flexibility there, of course. So again, trade-offs, maybe good, maybe bad, hard to say. Always require attestation? I don't know. I wouldn't classify this as a vulnerability. I would classify this as you need to be aware of this for your organization and decide what you want to do. All right. Again, FIDO keys are more secure, so that's fine. If you're not so nice, if I had to come up with how I was going to attack this, if I could get somehow in your browser and I could get that web extension in there, I would immediately stop your keys from working. The user would probably then go through some sort of key re-enrollment ceremony, at which point I would take over and I would have that newly registered key. I would then be able to use that from then on. I would then be able to exfiltrate that key and ideally profit or do something else. I don't know if there's a great way of preventing this unless you go back to attestation, which is where you have other problems and maybe infringe upon usability that users have there. So the moral of the story, don't blindly trust a browser. If you're at this conference and you're blindly trusting the browser, you're probably had a rude awakening or otherwise, right? Vendors try as best they can, but they don't always get it right. So in this particular case, be a little more aware of what your attack surface is here. Attestation can keep out some of the riffraff, but it'll certainly increase complexity. And you may or may not want that for your environment. It may reduce the number of people that can use FIDO, which would be, in general, a bad thing, as you would then be leaving them with passwords or maybe other things that would be a much worse form of authentication. And FIDO is more secure in every way than using a password. All right, so I just want to leave that with you. If you're intrigued, love to chat. Interested, if people are interested in this as a toolkit and what else can be done here. I think this is a poorly explored corner of the world. There's a lot of, quite a few vendors now offering hardware keys, which I think, being hardware are probably in pretty good shape. But now that platform authenticators and being done inside the browser is getting a little more interesting here. And with that, thanks. And happy to take any questions because I think we've got time, right?
So everything you demonstrated is about the software keys, the platform authenticators. If I was using a YubiKey, none of those demos worked.
As soon as I'm in the browser, you don't know what you're using, right? You might think you're using your YubiKey, but if I've taken over those credentials navigate, credentials create.
But you'd have to have been there at the enrollment process.
Correct. Or I'd block the key from being used. As a general user, you would not want to call the help desk, so you would re-enroll, and then good times, right? Other questions?
When you're in the browser, can you proxy the data that you're getting?
So the question is, when you're in the browser, can you proxy the data? Like off the box? Sure. I mean, if your web extension has the abilities to do that, right? I mean, in the manifest, you have to enable certain abilities to go in and out, and that's where my JavaScript was failing me pretty good. But yes, I don't think there's any reason why you couldn't, and I think there's actually a product, I think there's some out there, cloud-based FIDO keys, where it's a good thing, right? Keep your P256 keys in an HSM. That's fantastic. And this would be one way of doing that. Other questions? Thank you very much. Enjoy lunch.